In this screen capture, we're looking at, again, model data from the day of the MAR555 cruise. And we're going to a different model. So this is also part of the NECOF's Northeastern Coastal Ocean Forecasting System. This is the regional scale model. As you can see, it's much larger. Well, the other one was just a piece of Buzzards Bay, but the local scale model we're looking at before is roughly the size of Massachusetts coast, with the inclusion of Cape Cod Bay up to New Hampshire. This is the regional scale. Let me just turn off for a second the wind vectors. So this stretches essentially from the top of the Scotian shelf. This is Nova Scotia here, all the way down to New Jersey, and give me 1 second here. Let's go through this in here, get a little clearer. These are the major rivers of the Gulf of Maine that supply fresh water to the Gulf of Maine. Of course, there's a lot of fresh water coming in through the St. Lawrence Seaway. I put the bathymetry contours on here. You can see the shelf break roughly here at the 100-meter isobath. And you have, here's the cap of Georges at 60 meters. And then the deep basins of the Gulf of Maine are roughly extending to 300 plus meters. Wilkinson, Jordan, and Georges, which is Georges Basin, which is right here adjacent to Georges Bank. And then we have two controlling sills into the deeper waters of the Gulf of Maine. There's the Northeast Channel, which is about 220 meter controlling depth, and this Great South Channel, and I can't remember what the depth is. I want to say 70 something meters, but I can't remember offhand, so don't quote me on that. And definitely shallower than Northeast Channel. So we're going to look at, what you're looking at here is the wind magnitude on that day, meters per second. So multiply by 2 to get knots. So this is 30 knots, 30 plus knots here, 35 knots of wind. This was the nor'easter we were concerned about. I can put the vectors back on. As I mentioned before, the vectors are a little messy because they're on every grid point. And again, the grid's not regular. Here you can see the underlying grid. And if I eliminate just for a second the bathymetric contours, you'll see how the grid's very, very clustered along the shelf break, around the tidal mixing front in Georges Bank, along the Massachusetts coast here, much higher resolution. So that's the effect that you're seeing there when you see the wind vector. So let me start at the beginning of the day. So we were concerned about this nor'easter, which actually is out of the domain here, the low pressure. It's a low pressure system in our hemisphere. This is essentially, it's a storm that's rotating counterclockwise or cyclonically. It was moving up the coast. Miles was watching the weather, and the concern was it would come closer to us, inducing stronger winds, but it just kept going further and further offshore, which ultimately resulted in a decent day in the water. So you can see in our part of the domain here, it looks like it's just moving from the northeast, but if we were to have a large-scale domain, you actually see that the winds are fully cyclonic, and people are actually experiencing southerlies out here. So it's inducing these kind of winds, and typically as a nor'easter goes by us, we first experience these easterlies. As it goes past, we experience the northeasterlies, and then the next day when it's up here, we experiencing the northwest winds, and that's exactly what happened. Let me increase the size of my mouse here. That's what happened our day on the water. We experienced right when it was blowing northeast. So let's go about halfway through the day. You can see the storm propagate through. It's a pretty cool ring here. Here's the center. You can see this band, very tight band of high magnitude winds, north or northeast. Strong, definitely northeast over here, but further from the storm center, weaker winds. And then we won't have it here, but the next morning, after the storm has gone a little bit further up, you're experiencing this wind direction. You were in the southwest quarter of the cyclonic circulation, and there were light northwesterlies the next morning. But this is the day we were on the water. It's essentially a no low pressure zoom by out here. This is about the time we were on the water. You can see where the northeast winds are coming from. So we'll discuss in class how the Earth's rotation influences these systems, and why these low pressure systems are associated with winds that spin counterclockwise or cyclonically, counterclockwise in our hemisphere. And this is the low pressure is the same sense as a hurricane, is also low pressure but just stronger wind. I don't know what the pressure of the storm was, but this produces these northeast winds. If you give me 1 second, we'll have a look at the resulting wave field. So I'm going to turn off the wind vectors for a moment, and I will turn off the wind magnitude. Let's switch it over to wave magnitude. I'm going to readjust the scale. So this is essentially about a 4 meter significant wave height. So that's 0 to 4, 0 to 3 waves you're seeing under the storm. This is wave magnitude, and I could put the wave vectors on here, although they're probably going to be a little clunky, but let's put them on there and rescale them so we actually see something. Too big. Too big. Pretty good. So let me get rid of the grid. Now, okay, so there's the vectors, the wave vectors. So the waves are influenced by waves, by wind, by previous wind, and then refraction as well as controlling their direction. So in this case, you can definitely see this response to the local wind forcing of the waves. The peak significant wave, this is HS, significant wave magnitudes, occurring somewhere in the vicinity of the storm, and it just decays as you go further away from it. If I can also plot, if you give me a second, the peak period, which ranges from about 2 to 12 seconds. The way the model is discretized, so this, I should mention, these are predictions from a model. So what Chen has set up is he has a large scale model running on here called WaveWatch. Internally in this domain, he has a model developed here at UMass Dartmouth called S-Wave. These are phased average models. Essentially, they take the wave spectrum, how the energy of the system is decomposed into different wave frequencies and different wave directions. So it's discrete in that sense, and then that spectrum evolves, that energy spectrum evolves with wind forcing. We'll modify it, essentially increase longer periods, larger amplitudes, and then the spectrum will dissipate due to bottom friction, white capping, overturning, basically those, and then the waves themselves interact. So a spectrum, even without any forcing at all, the spectrum will interact with itself to modify itself. So you're not resolving, the numerical model doesn't resolve every wave. I used to say that that's impossible, but I saw a rather disturbing simulation recently that had 18 billion computational cells where there actually are resolving every wave. However, it's in a very small box, 200 meters by 100 meters. I'm not sure what it is. So probably the most impressive calculation I've ever seen. And so the time will come when maybe, who knows. But presently we're looking at spectrum. That's why you see here significant wave height is a continuous thing, is computed from all the quantities. It's diagnosed. The length scale here, because we've bucketed the frequencies of the waves, we're essentially bucketing these length scale. You have these discrete numbers. That's why these numbers sort of jump here between, I'm not sure how many frequencies Chen used. I think probably, my guess is 48 frequencies. So that's what you're seeing here, that kind of banding. But again, the range is you have longer period waves interacting. Of course, when things get on the shallow waters, as we discussed, that will change their period. So it's interacting certainly with the bathymetry, probably over Georges in a large storm like this, definitely when it gets to the coast. And then the other trouble is when you have essentially zero significant wave height in the model, you sort of have to ignore the parameters, or the other parameters are coming out, because there's essentially no wave exists, but you're still trying to say something about the peak period of nothing. It's sort of a meaningless discussion. And okay, so that's about it for the large scale approach. Again, we saw the system just sliding by. I think what I will do is just make another video zooming in on Buzzards Bay. Again, the low pressure was out here, producing the northeast winds up here.